Okay, we're going to talk about how we graph inequalities today. This goes over over the integrated algebra standard geometry 6, which is graphed linear inequalities. Okay. All right, so first we're going to talk about the order property of real numbers. Now, for all real numbers x and y, either x is less than y, or x is greater than y, or they're equal to each other. So anytime you put down a real number, like let's say that you put down 4 and 5, well, it's either this situation, or this situation. So clearly 4 is less than 5, so it's the second situation. We can do this with any real numbers. I just chose integers, so if I chose like pi and the square root of 2, okay, those are irrational numbers, but they're still real numbers. So we can see that pi, approximation of pi would be 3.14. That's not pi, but that's an approximation of it. And the approximation of square root of 2 would be something like 1.2. So you can see that pi is greater than the square root of 2. Okay, so it's either this situation, or this situation. For any two given numbers, either the first number is less than the second, the first number is greater than the second, or they're equal to each other. That is called the order property of real numbers. Or, another way of looking at it is you can put them in order from left to right. The numbers more to the left are less than the numbers more to the right. So, if I'm given a list of real numbers here, I can put them in order. So, 3 is less than pi, but 5 is greater than pi, and 2 pi is greater than 5. So I can just put them in numerical order there. Okay, so we have, let's see here. Okay, another property that goes with inequality is the transitive property of inequality that says that if x is less than y, and you also know that y is less than the third number z, then the first number is less than the third number. So if I put some real numbers in here, you could see if 1 is less than 2 and 2 is less than 3, then the first number, 1, is less than the third number, which was 3. And this works for any three numbers as long as you establish the order. So let's see, if 10 is less than 15 and 15 is less than 16, then what can you say about 10 and 16? Then you know that 10 must be less than 16. The first number is less than the third number you introduced there. Okay, that's called the transitive property of inequality. Okay, let's talk about graphing inequalities. There's two main types of inequalities. There's the strict inequality. They call it the strict inequality. That's when it's not equal to the number. So x is greater than 5 means that x cannot be equal to 50. Sorry, x is greater than 50 means that x cannot be equal to 50. And x is greater than or equal to 50 means that the first number x can be is 50. Greater than or equal to. So the greater than or equal to, this little symbol means equal to. So it means that whatever the variable is, it actually can be equal to the number on the right. An open circle is placed on the number line to show that the number denoted at the circle is not included in the solution set. So some numbers included in the solution set of this inequality would be 50.1, 50.2, 50.3. Those are just a few numbers. 51 is also included. So what we do is we put an open circle. So you can see here that's an open circle at 50, meaning I don't shade 50, so it's not included in the numbers that make this inequality true. And then you sort of shade to the right, including, you need to always shade the arrow, because that says not only do you shade the numbers just beyond 50, but you shade the numbers going off into infinity. Okay, notice that I'm not shading, the first number I'm shading is not just 51, right, because there's plenty of numbers between, so I don't just take 51 and put a closed dot there and start shading to my right. I shade any number to the right of 50, because the numbers like 50.1 or 50.01 also make this inequality true. They're just slightly bigger than 50, but that's okay with this inequality. It doesn't say that x has to be an integer. It just says that x has to be, since they didn't specify what x is, we can assume that x can be any real number. Okay. Alright, so the next thing that we're going to go over is when it is x is greater than or equal to 50. If it's allowed to be equal to 50, then we place a closed circle on the number line to show that the number denoted at the circle, so in this case it was 50, is part of the solution set. So I can put 50 into this inequality and have it be true. Okay, so 50 must be part of the solution set to this inequality. So I put a closed circle, so I take a circle and I fill it in, and I shade all the numbers to the right, including the arrow. Okay, the arrow means that you're shading off into infinity. Okay, so let's get some practice graphing some inequalities. The first inequality is x is less than 3, so you might want to pause the video here and use what you just learned in order to try graphing these on your own, and then, you know, go back to the video and see if you've gotten them right. Okay, if x is less than 3, then I want to put an open circle at 3 because it's less than 3, it's not equal to 3. Okay, and I want to shade all the numbers on the number line that are less than 3. So when I shade the number line between the integers, right, so like this space right here is between the integers of 0 and 1, 0 and -1, so I'm shading all that space to indicate that all of these numbers are less than 3. Now, how many numbers are less than 3? Well, there's an infinite amount of numbers less than 3. Okay, because there's an infinite amount of numbers even between two integers. So there's an infinite amount of numbers that is part of the solution set to this inequality. So when we talked about sets before, we said that some sets contain an infinite amount of numbers, and this is one of the sets that would contain an infinite amount of numbers. The solution set to x is less than 3. So if the domain is all real numbers, then remember the domain is the numbers that you consider putting into the inequality. So if I'm allowed to consider putting into this inequality all real numbers, then my solution set, which are the elements in the domain that make the inequality true, my solution set would be all the numbers less than 3, and that's, you know, an infinite amount of numbers. Okay, x is less than or equal to 3, so the only number that's included in the second inequality that's not included in the first inequality is the number 3. So I'm going to put a closed circle at 3, and again shade to my left. Okay, and you want to shade the arrow too, because that bold the arrow, so that makes it known that you are shading off into all the numbers that are not shown as tick marks. Okay, x is equal to 3. Well, the only number that's part of the solution set, right here, if the domain is all real numbers, the only number that's going to work here is the number 3. Right? So the first two inequalities had an infinite amount of numbers in the solution set, whereas this third, it's an equality. The third equality only has one number in the solution set, and that is 3. Alright, x is greater than 3, so I put, it's not equal to, so it's a open circle. Okay, this is a strict inequality, meaning it cannot be equal to that number, it has to be strictly greater than. So I put an open circle at 3 and I shade to my right. Whereas x is greater than or equal to 3, I put a closed circle at 3 and I shade to my right, including the arrow. Okay, so make sure that you have this in your notes. Okay, so another thing that you need to make sure that you have in your notes is the multiplication property of inequalities. So let's say that we start with a true sentence. All right, so I'm at this point in the table. So 9 is greater than 2. We know that 9 is greater than 2. But what happens when we multiply both sides of the inequality by 3? So 9 times 3, and what is the order when we multiply both sides by 3? That's why there's a question mark there. 9 times 3 and 2 times 3, well, the result is 27 is greater than 6. So the order, the object on the left-hand side is still greater than the object on the right-hand side. Okay, if the order was less than, 5 is less than 9, multiplying it by a positive integer such as 3, the order remains unchanged. 5 times 3 is still less than 9 times 3. Okay, but let's say you start with the order greater than. 9 is greater than 2, and I multiply both the 9 and the 2 by a negative number. This is important. Okay, well, the order is changed here because negative 27 is certainly less than negative 6. Same goes with if you have a less than order. 5 is less than 9, and you multiply the 5 and the 9 by negative 3. The order is changed, absolutely changed. The inequality flips around. Okay? Okay, so we're going to use that information to do the example here. So using the inequality 10 is less than 12, write a new inequality after multiplying both sides by 4. So 10 times 4, and let's do a question mark here. Is it still less than 12 times 4? And the answer is yes, because 4 was a positive number. And the original inequality sign does not change. So this right here is greater than. So, 40 is less than 48. Okay, or 48 is greater than 40. But if I multiply both sides by negative 1/2, so we have 10 is less than 12, that's what we're starting with, and I'm multiplying both sides by negative 1/2. Let's try this in red here. So negative 1/2 and negative 1/2. Well, first of all, multiplying it by half wouldn't have changed anything except that we're multiplying it by negative 1/2. So 10 times negative 1/2 is negative 5, right? 10 times a half is the same as 10 divided by 2. So that's 5. A negative times a positive is a negative. And 12 divided by negative 1/2 is negative 6. So you can see negative 5 is greater than negative 6. So this inequality flipped around. Alright, so if you multiply both sides of an inequality by a negative number, you have to change the inequality around. Alright, the same goes for if you have, we've just been showing strict inequalities, but, 5 is less than or equal to 9. Well, if I multiply this side by negative 2 and this side by negative 2, I'd have to flip the inequality around, so it would end up being that, let's see, negative 10 is greater than or equal to negative 18. Okay? Okay, now we arrive at something called a compound inequality. A compound inequality is an inequality that's bounded both upper and lower parts. So this x is sandwiched, the first compound inequality is x is sandwiched between 7 and 10. So both of these things are strict inequalities. So x can't be 7 and it can't be 10, but it's all real numbers between 7 and 10. So when I graph it, let's put the 7, 8, 9, and 10 here. I want an open circle at 7, an open circle at 10, and shading in between. Okay. Now let's say that one of them is not a strict inequality, so I'm allowed, in the next compound inequality, I'm allowed to include 7, but not 10. So again, let's put 7 here, and since my pen is I can't write very fine, I'm just going to put 10 on the other end. You know that there's an 8 and a 9 in between. Well, here, I want to have a closed circle at 7. I'll take that and shade it in. An open circle at 10, and shading in between. Okay. Now let's say for the third inequality, they're both endpoints are allowed to be included. So I'd have a closed circle at 10, I'd have a closed circle at 7, and I shade in between. Note that the arrows are not shaded because there's endpoints here. Okay, if you just had x is less than or equal to 10, well, that would start at 10. Closed circle, and it would be shading all the way to the left, including the arrow, because there's no endpoint to the left here. There's an endpoint to the right. There's a greater bound, an upper bound, to what this inequality, to what the solution set of the inequality would be, but there's no lower bound. There's no least number in that solution set. Okay, now interval notation is a way to write the solution set as an interval of numbers. Right, and when we write an interval, we always include the smallest number to the left. So let's say that I want to write the interval between 3 and 4, and I want to include 3 and 4. I want to write 3 first, comma, 4, and I want to use square brackets. Now, I'll just show you with this this inequality here. If you can include the endpoint here, you want to use these square brackets. Oops. Okay, I lost some of my writing here, but it's okay. If I want to use, let's just start with this inequality that's right here. Okay, this one says that, if we recall, that was the 7 and 10 here, but with open circles, because I'm not allowed to include either one of them. There's no line underneath these inequalities here. There's no line like that, right? So I'm not allowed to include 7 or 10. So I'm going to use these rounded brackets. And I'm going to put 7 first because it's smaller than 10. And then I'm going to put 10, and I'm going to end with rounded brackets. The rounded brackets mean they're not included. Not included. Whereas we can use square brackets to mean, actually over here we're going to have a square brackets. Square brackets means included. The value is included. Okay, so for the second compound inequality, I'm including 7, but I'm not including 10. So I want to use a square bracket at the 7. So the lower endpoint is included, so I use a square bracket as opposed to the first one, which was a rounded bracket. So over here I use a square bracket for 7, and then 10, and I want to use a rounded bracket around 10 because 10 is not included. Okay, and if I were to translate this, if I were to take this interval notation and I were asked to graph it, then I would do exactly what I did before. I'd have a closed circle at 7 and an open circle at 10 because that is what the interval notation suggests. Okay. Notice you cannot write this as 10, 7 bracket. This is not, you can't write it like this because 7 would have to come before 10. 7 is on the left side of 10 on the number line, so it's on the left side of 10 in interval notation. Okay, so for the final compound inequality, notice that both endpoints are included, 7 and 10. So I'm going to put square bracket, 7, comma, 10, and square bracket, like that. Okay, because both endpoints are included. So if I were to translate that back into a graph, which I had already done the graph before, but it's sort of erased, but we can use this as an opportunity. I should be able to give you interval notation. You should be able to go from the graph and back to the inequality. From any of these representations, you should be able to get the other two. So this interval notation translated back into a graph would be closed circle at 7, closed circle at 10, and shading in between. Okay, closed circle is the same as a square bracket. The closed circle on a graph is the same as a square bracket on an interval notation. Okay, and the last thing I want to go over is how I write these inequalities in interval notation because there's only one endpoint here. So for this inequality, we want to include all the values that are less than 3. So you only have an upper bound here and you don't have a lower bound. There's no least number that's less than 3. It goes on to negative infinity. So the upper bound is 3, so you want to write that to the right, and it's not included, so use a rounded bracket. Now the lower bound is negative infinity, so you want to put the infinity symbol, put a negative sign in front of it, and infinities are never included. You never use a square bracket for when you write infinity. So the next one, x is greater than 4. Again, you have a lower bound, but you don't have an upper bound. So you want to put rounded bracket for 4. Okay, actually, let's make this a little bit more interesting and put it greater than or equal to. So then I would use a square bracket, 4, comma, and then the upper bound is just infinity, and you use a rounded bracket there because you never include infinity. Okay, so this inequality translates to this interval. This one right here is interesting because there's only one thing in the interval, so you put square bracket 4, and you end it with a square bracket. Okay, so that just means that the only thing included in that interval is the integer 4 and nothing else, which is suggested by that equality statement. X is less than or equal to 10, so you might want to pause the video right now and see if you can't do this by yourself and come back. Okay, because x is less than or equal to 10, so you have an upper bound which is 10, so that's going to go to the right. 10. You want to use a square bracket because it's inclusive. Okay, and you want to use a lower bound, which is negative infinity, and we don't include that. All right, so that's the end of learning how to graph inequalities, all right, and write them in interval notation.